morning, ladies and gentlemen. My name is Julian Klaus, and I am the host of today's Rutronik Connects webinar series. Today we have our last week of the Rutronik Connects webinar series. If you don't know the webinar series yet, we are having several weeks of wireless technologies, and together with our partner suppliers, we are talking about the latest trends and products in the wireless technology. This week is all about Bluetooth technologies. So the first week was all about Wi-Fi. Then we had some ultra-wideband LoRa stuff and cellular stuff. But this week is all about the Bluetooth technologies. Before we start with our webinar series, some practicalities beforehand. So the webinar is going roundabout or roughly 1 hour. So we have the introduction of me, and we will have our supplier partner talking about some Bluetooth low energy socks and software from Nordic Semiconductor. And if you have any questions, feel free to ask them in our question and answer sector in Teams directly. So at the end of the webinar, we will read out the questions, and we will have Nordic to answer them afterwards. If you have any questions later on, if you're watching the video on demand, for example, you can always contact me or Nordic directly, and we are happy to help you out with your questions. So, as said, my name is Julian Klaus. I'm a corporate product manager here at Rutronik in the wireless department, and today we have PAwR from Nordic. He is Senior Product Marketing Engineer. And welcome, PAwR. May you like to introduce yourself again? PAwR, your microphone is not working.
Oh, God.
Yes, now it's working.
Yeah. Hello, Julian. Thank you very much for the invitation. My name is Paweł Kanafek. I'm in product marketing engineering team at Nordic, and I'm happy to present a few things about Bluetooth Low Energy and our offering today.
I'm very glad having you here. So would you like to share your presentation?
Of course.
Okay, nice.
Okay, so the topic of today's webinar is Bluetooth Low Energy and in the context of ultra low power. So we'll be talking about ultra low power solutions with modern Bluetooth Low Energy socks and software, as software is the major part of every Bluetooth Low Energy product nowadays. First, the agenda. We'll start with the overview of the solution. We'll go through the software, SDK, and tools. I will present also a few highlights about the new nRF54L series. As I know, many of you are excited about this new product. And we'll talk about two not very well known features of Bluetooth Low Energy, which are Channel Sounding and PAwR. And I will finish with the demo of PAwR. It is a slide-based demo, but shows a hands-on experience on how to start with PAwR and how to achieve ultra-low power consumption. So as I said, Bluetooth LE chips are the key part of every product, and we provide a variety of these socks, differing with sizes, packages, feature sets, and so on. So anyone can pick a chip that suits their needs. But also, we have very well-known Bluetooth LE stack with high-performance controller and modular host, and a broad selection of development software and tools, starting with nRF Connect SDK, tools for development of wireless products, and mobile apps. We also provide world-class support with Dev Academy, which is a interactive learning platform with multiple comprehensive courses. We have DevZone with our tech support ready to answer any questions from anyone. So it's an open support. It's not gated. And we run Nordic Tech Webinars, we run Nordic Tech Tours, and if anyone needs help with design or implementation of their products, we have a network of trusted design partners and solution partners. Every year we run a survey asking our customers what they value about our products. And what we very often see is that the strong portfolio of high quality socks is valued for the flexibility of choice that it provides. Interoperability is sometimes underestimated value of Bluetooth LE offering, and we can assure that our Bluetooth LE controller provides the top-notch interoperability. Very often, our devices are used as golden samples while inspecting interoperability issues. Of course, low power is in our DNA, but recently we have been moving on to higher performance solutions with more processing power, but still remaining these ultra low power capabilities. And we are developer oriented. So we provide a range of tools. We care about these, and tech support and Dev Academy are the places to go when you want to either start working with Nordic solutions or need further support. I have selected a few success stories with the products that are in the market, as our Bluetooth LE chips can be implemented in multiple different products. So smart rings are the new product category, slowly overtaking the place of smart bands, sometimes watches, providing some information about the health or measuring heart parameters. And this combines all features that we provide, which is ultra low power, as there isn't much space for the battery, small size, and also this customer valued excellent performance and development community. Dr. Dharma Tabs is a kind of innovative product, not very common product category. And this customer valued help and support, and also LTK documentation while they were making this product. And in the top right corner, you have one of the first LE audio devices, as audio hasn't been possible to be implemented with Bluetooth Classic, and now it is with Bluetooth Low Energy. Because we are Bluetooth Low Energy, we like to say that audio came to us. So it's now possible to implement LE audio products with Nordic chips. It's possible to do it with 53 series, and will be possible with upcoming 54H series. Well, this approach and this set of items that we offer enabled us to reach the leading position in the market. So as you see in the left, we cover over 40% of all qualified products. And that's the stats from last 5 years. In terms of volume, we have already delivered billions of Bluetooth LE chips in total, and on average, we're shipping 2 million socks a day. And because we are very open, and we can support all kinds of customers from startups up to global enterprises. So now we'll move on to a little bit more detailed part, starting with NRF Connect SDK. NRF Connect SDK contains a number of features. I have a stack or architecture of it in the following slide, but it contains Bluetooth stack with this great interoperability that can be underestimated. It's based on Zephyr. Zephyr is a small scalable RTOS optimized for resource-constrained devices, but it's not just the RTOS. Actually, it opens the possibility to reuse vast range of resources provided within this project. So we like to say that it has battery included, as there is security, stacks, drivers, samples, lots of stuff and modules that can be reused easily as it is compatible with NRF Connect SDK. NRF Connect SDK is optimized for ultra low power and minimal memory footprints. That is everyday struggle for many engineers, and it's also mature and popular. So we have the most popular SOCs and this powerful software also merged with the fastest growing RTOS community, which Zephyr is these days. In terms of the overview of architecture, in the left you see that major part of your application can be covered by out-of-the-box software resources. Some of them are provided as binary, such as soft device controller, but majority is provided as source. The goal is to provide a broad selection of samples, libraries, and modules ready to be used. So it's possible to focus on building the application, providing value for customers, not developing low-level software. So when we deliver that, we have this many customers, so we get lots of feedback. Based on that, we improve it with every release of NRF Connect SDK, which is released roughly every quarter with many improvements and optimizations. The Bluetooth LE stack is qualified, and whenever a new specification is released, we tend to qualify as fast as possible to the newest standard, also adding new features, of course, all mandatory features, but also many optional features. How NRF Connect SDK is created is that with every release, we combine our own part of software, our own repos, which contain a few features, like not a few, but it's quite large. But we combine our repos and Zephyr repos, so you don't have to do it for yourself. It's all in one package. So from our repos, we provide the firmware for Nordic SOCs, such as peripherals, radio, etc. There is soft device controller, Bluetooth libraries with samples for GAT profiles and other features of Bluetooth. And we qualify it, as I said. And from Zephyr project, there you get that access to reusable drivers and modules. Zephyr is made for low power wireless, and this project benefits from contributors from many companies. So we also contribute a lot and cooperate with leaders in the industry. All that combined makes the NRF Connect SDK. So we have the SDK. This is a software resources, basically repos, but then you need tools to fully utilize it. When you will work with Nordic, or when you work with Nordic, the starting point is getting VS Code and NRF Connect for VS Code extension. This provides development environment, building, debugging, and more. As you can see, NRF Connect for SD code has been downloaded for over 120,000 times already and got quite good opinions. In the extension pack, you also get the NRF util, which manages repositories and provides the SDK in one package. What it does, it installs the SDK version with one click. Then you can select from the SDK versions that you have installed which one you want to use for your project. There is also kconfig that configures source files that are meant to be pulled into the project. Device tree for hardware configuration. There is also a GUI interface for device tree, and more tools like NRF Terminal, Memory Explorer, Toolchain Manager, and a few other tools that are necessary while developing. Apart from the tools for directly oriented on development of code, there are some helper tools in the NRF Connect for desktop. It is a bundle of multiple tools, including NRF Connect Bluetooth Low Energy, which is a desktop tool that can act as the central peripheral. It can be like it can emulate the peer device to your project. It also contains a sniffer for Bluetooth Low Energy. That's a very nice thing. All you need is a NRF 50 to 840 dongle, and the software for sniffer comes for free. So it provides comprehensive sniffing capabilities at a fair price. There is also RSSI viewer and a few more applications. In terms of mobile applications for Android and iOS, we have the approach always is that we create a library that is open source and can be used in the application. It provides, for example, LED button service, Nordic UART service. These are custom GATT profiles that are very often used when you want to create a custom, your proprietary custom profile, or just push the data from point to point that a Nordic UART service is for. So these applications are offered as samples or tools. So samples are the open source apps that can be used as the starting point for development. But there is also NRF Connect for mobile, which is a closed source tool, and it provides multiple features. So it can act in various roles in Bluetooth setup. It provides information about contents of data sent over the services. It has the macro functionality and a few other things that you can discover for yourself. As you can see in the top right corner, it is quite popular. I know it's quite a lot, but there is Bluetooth Low Energy Fundamentals course in the Dev Academy that I mentioned. It guides through all items necessary to understand to start developing. After taking this course, which takes 8 to 10 hours, you will go through the entire setup of your Bluetooth project, and you will end up having a connection with mobile phone and being able to blink LEDs through the mobile app on the board with the complete connection, GATT service, and there are also information about how to run Bluetooth sniffer and how to debug Bluetooth LE applications. NRF 54L15. which is the first product that has been announced in nRF54L series. It is positioned as the next level wireless SoC because it's set to succeed the application range that is currently being covered by a very successful nRF52 series. So it's also a single processor SoC with lots of improvements. I don't have slides about 54H series, so maybe a few words here. nRF54H series will be a multiprocessor, way more powerful in terms of processing power. That's why it's presented higher in this chart. So it's intended for more demanding applications that require more processing power. L15 combines or integrates ARM Cortex M33 processor running at 128 megahertz, increased amount of memory with 1.5 megabyte of non-volatile, 256 kilobytes of RAM, the radio capable of running Bluetooth Low Energy and IEEE 15.4 protocols such as Thread and Zigbee, and with the support for Matter ecosystem over Thread, and also 2.4 gigahertz proprietary protocols. So it's possible to use either Nordic's proprietary protocols or develop your custom protocol. 54L series has many improvements compared to nRF52 series, which is still very popular. It provides doubled processing power with reduced power consumption, expanded memory, this new radio that I will talk a little bit more about, advanced security, and it's offered in ultra-compact packages for size-constrained devices or designs. So in terms of processing performance or processing power, it's based on CoreMark. It doubles the performance of 52 series, and also it doubles the processing efficiency. So what it means that compared to nRF52840, it's possible to do more computation at lower energy cost. The radio has multiple improvements, including finer output power configuration with 1 dB resolution. That's mostly useful when it's combined with a range extender or front-end module, as you can call it, which provides output power up to 20 dBm. It consumes 50% less power in RX mode, and for 2.4 gigahertz proprietary protocols, it has a new 4 megabits per second data rate. So it's twice as much as it has been possible in 52 series, as it had only 1 megabit and 2 megabit per second mode. It also supports Bluetooth 6.0 features. And the key feature of Bluetooth 6.0 is channel sounding. Channel sounding is the new feature for ranging or distance estimation. With the reliable information about the distance, it's possible to deliver improved presence detection and estimate distance for applications that require information about physical context. What's nice about channel sounding is that unlike direction finding, it doesn't need extra hardware components. It can run on a single antenna. It can run on more antennas to improve the accuracy or latency, but it can run on a single antenna very well. it has a security built in by design. It provides interoperability between devices. We are looking forward to seeing the support in mobile phones. And it also consumes as much energy as regular Bluetooth Low Energy. There are two methods in channel sounding that are used for ranging. PRB, phase-based ranging, is the first one. So in channel sounding setup, there are two devices, the reflector and the initiator. So the measurement here is based on the phase shift of the signal sent by the initiator and returned by the reflector across multiple frequencies. It provides accuracy aimed for applications like smart door locks, home appliances, and Find My tags or smart tags. So it's not like millimeter accuracy. It provides good enough accuracy for this kind of applications. The specification defines radio features, stack features, security measures, and measurement procedures that is needed to collect raw data. Raw data is converted to distance using dedicated algorithms that is performed at the application level. So this is not defined by the standard. So then this industry is working on implementing these algorithms now, and we have seen some results already. Another method for ranging is RTT. This is a way simpler method, and the distance is calculated based on the time it takes for the packets to travel back and forth. So it's very easy to imagine. These packets are cryptographically scrambled by default. It can be used standalone for coarser ranging over longer distances, but the primary function of it is to act as a cross-check source. So the phase-based ranging measurements can be cross-checked with the results obtained by this method. So it's possible that with PRB you can get like very strange results due to reflections or multipath effects. So round trip time can be used to cross-check and remove unreliable results. It's a way simpler algorithm, so, and can be used standalone. There is a built-in security in channel sounding. So before the measurements, devices need to pair and establish an encrypted ACL connection. That's something different to what we have in Nordic Distance Toolbox, which is an alternative to channel sounding available now, where Nordic Distance Toolbox doesn't require this connection, which can be seen as a constraint of channel sounding, but on the other hand, it significantly improves the security of it for applications such as locking devices, unlocking cars, and stuff like that. There are several specific ranging mechanisms, including for security, including randomization, defense against symbol manipulation, and attack detection to provide the security of the measurement itself. And this cross-checking is another security measure. So there are a few things that we particularly like about channel sounding and are happy to see it being available. So the power consumption is as low as a regular data transfer. So in both methods, there are regular packets sent over these the range of frequencies, or so it doesn't take more energy than the regular Bluetooth connection. It's standardized and interoperable. It's applicable in very simple devices, such as smart tags. It can be added in the addition to the existing product when the SoC allows for that, and so it doesn't require additional hardware. And on the reflector side, it can be enabled with a minimal software footprint. There are different hardware and software configurations. So depending on the requirements, different accuracy, latency, and security level or power consumption levels can be achieved. And mobile phones are expected to open the range of possibilities, because in the context of channel sounding, the power consumption shouldn't be a problem, or isn't a problem at all on mobile phones side. So they can act as initiators and do the algorithms needed to calculate the distance. And the peer device can be very simple and ultra low power. So channel sounding can be used in Find My tags, smart logs, for asset tracking of valuable assets, as like due to this constraint of necessary connection, it can be used in like setups where hundreds or thousands of items are tracked. And also appliances is a nice example of a channel sounding use case. For example, when multiple devices needs to be provisioned, information about the position of the user in the environment can be helpful. All right. PAwR demo. So PAwR is another feature of Bluetooth, quite new, but in the context of ultra low power consumption, it opens a range of possibilities in products that need some networking. So general idea of PAwR. So it is a bidirectional communication in connectionless mode. That hasn't been possible before Bluetooth 5.4 was announced last year. It provides one-to-many communication, so it's different than Bluetooth Mesh, for example, which provides many-to-many. So there is like central node and peripheral nodes. It can provide ultra low power with end nodes. And how it works. So advertiser sends data at precisely timed intervals. So we have advertiser here, and it advertises. It sends advertising packets in these precisely timed intervals. So scanners are in RX mode only in this specific time to save power. Each scanner can communicate back with the advertiser if needed. That's the difference to regular advertising that has been available before. So there are specific slots after advertising packets where scanners can send their responses. And there is a possibility to set up a connection. So in the response, so in the advertising packet, the advertising can request a scanner to connect, and after the connection is established, higher throughput can be achieved for DFU, for example, or updating an image on the electronic shelf label, and other features can be implemented that require higher throughput. Now we're getting a little bit more detailed. So to set the stage for the following implementation demo. So here we have the complete PAWR event. So first, advertiser initiates the PAWR event at every periodic advertising interval. As you can see here, this is the beginning of the periodic advertising interval. PAWR event can contain multiple sub-events, but scanners can subscribe to selected sub-events to save time spent in ActiveTX mode. So here we have these sub-events. And response slots are located after every sub-event. So, and the orchestration of responses has to be solved on the application level. So application have to implement the mechanism to figure out which device responses in which response time slot. Some performance and specs for PAWR. Maximum number of sub-events is 128. And max number of responses slots is 256. So as a result, a network with a single advertiser or the central node can handle over 32,000 devices. So this technology has been created with electronic shelf labels in mind, and there is a electronic shelf label profile available. So you can see that this number addresses the need of large-scale networks with ultra-low power end devices. Latency can be configured in a range from like single milliseconds to over 80 seconds. It's possible to send more data with regular Bluetooth LE throughput after establishing a connection. Use cases, ESL, that's the primary use case. We have a dedicated dev zone page that you can find with this redirect link. But ESL is not the only use case for PAWR. Any large network that required ultra-low power end nodes can benefit from PAWR. And these networks can be like environment monitoring, asset monitoring and tracking. It can be used with smart buildings, industrial automation, or healthcare. So now we'll proceed to the demo. So this demo is based on the course that has been developed in cooperation with Novel Bits. You can find the complete course at this link, and it shows in detail how to implement this demo or this project, this scalable weather station system. But in this presentation, we'll focus on a few aspects to highlight how the low power consumption has been achieved in this project and how to use the tools that we offer that I described in the beginning to achieve ultra low power and how to implement and run the samples for PAWR. I will go briefly through the components of this demo. So in this picture in the left, in the top, it's a little bit hidden, but there is a sensor collector node, which is the advertiser in PAWR setup. And here we have a sensor node with e-ink paper displays for low power, and temperature and humidity sensor. In this setup, we have only 3 sensor nodes, but it can be up to over 32,000 with PAwR. And there is also NRF Connect for mobile application used to connect with the sensor collector node to get the data and display it easily, as the sensor collector node is implemented with a bare NRF52 DK with no peripherals, no displays on it. Setup and functionality. So we have the sensor nodes based on NRF52 DKs, a sensor, and the e-paper. A bare NRF54 DK acting as a sensor collector, and NRF Connect for mobile application. So sensor nodes act in the role of PAwR scanners. They read and report sensor data and displays the data on the e-paper display. Sensor collector acts in PAwR advertiser role and collects the sensor data from all sensor nodes and sends to NRF Connect for mobile application running on Android phone. In this setup, we have used a number of tools that I have presented before. For software tools, we have NRF Connect for VS Code extension, for coding, building, debugging, etc. And from the software resources and from NRF Connect SDK, we use Soft Device Controller, Zephyr Host, PAwR samples, and a few third-party modules pulled from Zephyr, LVGL graphics library, and State Machine Framework. Drivers are also pulled from Zephyr. These are ready-to-made drivers for Sensirion SHT40 and driver for the e-paper display, which is included in the LVGL library. We also use NRF Connect for mobile for this displaying data, which is the easiest way while prototyping. And from hardware tools, we are using PAwR Profiler Kit 2, a tool for measuring power consumption, which has a dedicated desktop application to display the measurements and analyze this. Before we proceed, one more mention about West kconfig and device tree, because I will be showing how to use these tools to build the application. So West is the repository management tool. It pulls the source files from the repositories. Kconfig configures which sources we want to use and how to configure the project. And device tree defines configuration of the target board. So with these tools, it's possible to scale and port the application to different targets. Okay, and now I need you all to focus as we're going to go into a few details of the code. I will highlight a few interesting points from the course. You can find the complete implementation and step-by-step guide in the full course. I will show a few examples of basic concepts, like how to download samples, how to initialize PAwR, and how to add a sensor to the project. And I will talk more about the power consumption optimizations and how it has been approached here. So enabling PAwR starts with samples. The samples used in this demo allow two devices to exchange data over PAwR right out of the box. just after downloading and running these samples on the DKs. So for this demo, we have two samples, PAwR advertiser and PAwR synchronization. Downloading samples is streamlined with the NRF Connect extension. First, you need to create the application. Second, pick the sample and copy it, and after selecting the sample that you need to use. So for this project, you will need to pull two samples and then compile and run it on these four boards. Here I have a little bit of pseudocode to show how easy it is to initialize PAwR with these samples. First, you need to initialize Bluetooth Low Energy, register callbacks for the event from PAwR, and subscribe to the events that will be then served by these callbacks. And it's 1, 2, 3, and PAwR is almost ready to run any MVP or demo project. Adding a sensor node, first it's necessary to initialize kconfig to enable print for debugging I2C sensor library and the library for the specific sensor. And then in device tree, it's necessary to initialize the hardware for this device and register its address. So adding a sensor support after it is initialized in kconfig and device tree is straightforward. So it requires initialization and implementation of function to capture the data with sensor sample fetch function and from SHD sensor, which has been initialized here. And that's it. The data is already in here. We get this data and decode temperature and humidity. So these were a few examples on how straightforward it is to set up PAwR, how to set up the sensor. I haven't covered in it of the e-paper display, but similar tools and techniques are used for that also. So now a few steps to optimize the power consumption. First, how we approached that is we estimated the power consumption during Bluetooth activity and in sleep modes using the online power profiler tool. Online power profiler is available at DevZone. It supports all chips from Nordic, and it's possible to set a given setting for Bluetooth and see the power consumption in this given setting. So this is a good benchmark of what you should expect on the DK after running the actual software. There are a few things to remember while doing that I will describe in a moment. We also estimated the power consumption of the external hardware based on the data sheets, so we know that what we measure is what we expect. And then it's necessary to disable debug and tracing features. These are enabled by default in all samples. Because we had to make a choice, whether always enable that or disable that. We went with enabling that. So it's necessary to remember that when you want to see the actual current consumption, it's necessary to disable that, and sleep current shows that it has been done successfully. And in the fourth step, we will identify separate features and see it on the PAwR Profiler kit on the hardware, and we'll check against the expectations. So first, the sleep current. The goal is to achieve single microamps, but here we see that it's over 700 microamps. So that's unexpected, or expected, you could say, because you already know that it's due to enabled debugging and serial port. So we need to disable these features for actual measurement. So, and after disabling serial port with this kconfig setting, after disabling logging and after disabling console, we are down to 3.4 microamps. That's what we expect. And that's what you will see in the online PAwR profiler for 50 to 840. Now we identify a key point to check. For the demo, we'll focus only on the 3 key operations for sensor node. So PAwR, RX, and TX event, updating the ePaper display, and capturing the sensor readings. So we do run a PAwR event, identify it, where it is in the trace, and here we can measure how much charge has been consumed in this event. So here we can see that it consumed 8.75 microcoulombs. Then we go to temperature sensor reading, and here the charge consumption is 0.76. And for humidity, we get 1.14. Combined, total sensor reading consumes 1.9 microcoulombs, which is within expectations. And then we want to see how much energy ePaper update display takes. So we have identified this event into trace, and we see that it consumes 8.47 millicoulombs. That is expected, but that's not ultra low power. And so we know that we need to minimize the number of ePaper updates to achieve long battery life. So in the summary, we see how much these 3 activities consume. And what we can do about it, basically reduce the frequency of updates of all 3 operations. And to summarize this exercise, we went with the following settings. So we decided to update the readings and report it over PAwR, or request it from the sensor collector. Sensor collector requests the update every minute. And we have collected the charge consumed per 1 minute, but we excluded the display update from this. We have also assumed that the display update occurs every hour. So it's not always up to date, but saves lots of current. So the total charge consumption per 1 hour is 1 ePaper display update charge plus 60 updates of sensor readings and PAwR events. From that, we get that the system consumes 53.2 millicoulombs per hour. So with this information, it's possible to theoretically estimate battery life in battery lifetime. So when we take a typical CR2032 coin cell battery with the capacity of 235 milliamps, we can achieve lifetime of almost 16,000 hours, which equals to 662 days. Of course, this is theoretical. It doesn't account for effects of temperature or like the usable capacity of coin cell battery and so on. However, this result is impressive to me anyways. So that would be it for the presentation. You can find more information about Bluetooth Low Energy solution from Nordic here. And you can subscribe to NRF54L series newsletter in this page if you would like to know more about this new product. It took me a little bit longer than I expected, but we still have some time for questions, right?
Yes, thank you, PAwR. Yes, there's a lot of questions, so let's jump right into it. So first of all, thank you for the great presentation. Coming to the questions, we have 2 or 3 times the same question almost. What is the accuracy of PAwR measurement? Or the second question is the accuracy between PAwR and RTT.
Oh, it's a tough question. So like some of our competitors do show some results. We are a little bit more careful about these, but I won't throw a number about the accuracy of PBR, but it's enough to see whether your smart tag is like under the pillow on your sofa, on the right of your sofa, or on the left of your sofa. That should be easily achievable, and we're expecting this capability to be delivered to the market. And difference in accuracy between PBR and RTT, I don't know the answer to this question. I'm sorry. You can reach out to me if necessary. I will try to help or ask on DevZone. There should be someone. There will surely be someone able to help if that's known at this stage of development of the technology.
Okay. Yeah, let's do it like this afterwards. Also, in comparison to PBR and RTT, what is the max length of measurement? So I guess this will be answered as well in DevZone afterwards.
Well, it's possible to measure within the range of Bluetooth connection.
Okay. Next one is similar. What is the estimated accuracy of channel sounding?
Yeah, I think that I already answered.
Yes, correct. So let's move on. When will the support for channel sounding in mobile phones be added? Do you know?
We don't know that. The information about OS's support is usually kept in secret, but we have already seen some symptoms in Android API that channel sounding is being worked on. So we're looking forward to see following Android and iOS releases.
Okay. So pretty fast already. Next question. About the NR54L15, what is the expected schedule for the release of the SOC? So I can answer it. If you wait 1 more week, you will get more information because next week is the official launch.
Yes, precisely.
Yeah. And also if you want, we have dev kits available. If you need one, you can always contact me. No problem. The next one is, in the PAwR demo, did you use the static or dynamic addressing of the sensor nodes?
It is a demo, so we have used a static addressing of demo nodes. It's hard-coded in that demo, so it's a thing that needs to be implemented in the actual system.
Okay. And the last question is for PAwR, can routers forward data to other routers not in range of the central node?
So I don't know precisely what is meant by routers, but okay, we have central node here. So the central nodes probably can communicate with each other. That's up to be implemented because central nodes doesn't have to be ultra low power. They will likely be powered by mains, but the PAwR scanners don't have the capability to forward the messages further. If such a capability is necessary, I would recommend to think about using Bluetooth mesh.
Okay. Okay. And one more question popped up, sorry.
Sure.
Can you provide bar metal examples, not Sapphire based?
That's a tough question as the NRF Connect SDK is the currently supported SDK, but there are libraries that can be used bare metal, but we're not supporting it publicly and broadly. So it's possible to use Nordic chips with bare metal, but we're recommending to use NRF Connect SDK for now.
Okay. Okay, fair enough. Yeah. So no more questions left, I see. If you have more questions or if you want to see more information, you can always reach out to our websites, newsletter, or social media, or more precisely, or if you have dedicated questions, you can always contact me. I will ask Pavel and his team. If it's too technical, you can always reach out to me, and you can see my contact information here, and I am happy to help you with your questions at any time. One more thing to mention is our last webinars for this week and also for this year. At the end of this webinar, we will have Kyocera for X presenting antennas, especially for the NR54. So check out the webinar later on. Also, we have tomorrow Inside SIP presenting NR54 based modules, and on Friday we have Infineon for also Bluetooth low energy content. As said, if you have any questions, even if you're watching the video on demand, you can always reach out to us. And if you don't have any questions now, or maybe Pavel, I wish you a good afternoon, and yeah, see you.
Thank you everyone for joining.
Yes, thank you, Pavel, for your presentation. And
thank you,
yeah.
Julian.
All right. Bye-bye.
Bye.